to finish up lesson 1.1, we're going to look at an application. And there's a lot of different ways to approach a problem depending on what you're given and the best way to use it. So in this example, it comes from example 9 from the textbook. We're going to do all three things. So a numerical approach would be if you made a table and used it. So you construct that table of values and use that. Graphical approach would be if you draw and use your graph to get an answer. And then an algebraic approach is using the rules of algebra. So this is like when you use your equation to get an answer. And in the example we're going to look at, we will look at all three of those things. So we're given this situation where a median recommended weight, Y, in pounds for men of medium frame who are 25 to 59 years old can be approximated by this mathematical model. And so here's what we're focused in on. We have this equation here for Y equals, so that'll help us with our algebraic part. We're given a range of Y values, or sorry, a range of X values. It says X there, not Y. Y is our range. So it's telling us our X values are only going, they're starting at 62 and they're ending at 76. Both are included because of the equal sign in our inequalities. So it's telling us what our X values are. They start, the lowest is 62, the highest is 76. That's our range. And then it says it defines X as being the man's height in inches. So this is already completed because we know how to do this. But if we look at the three different models, we have numerical here. And so numerically, we use our calculator to complete our table of the median weights between 62 and 70. Oops, sorry, that should say 76. Typo there, I apologize. Because it gives us the range of 62 to 76. And there's a lot of numbers between there. So notice when they filled those numbers in the table, they went by twos, and that's okay. You don't have to include every single one. We just want to use the values that we have to get a generic idea of what the graph is going to look like and what the information is going to represent. So there's our numerical. And then if we just plot all those points on our graph, we have our graphical version here. So our table of values uses that, and we can estimate based off of that. So if we want to estimate the height of 71 inches, we would go over and we would look about where 71 is, between 70 and 72. And then that's right above the 160 mark. So it's not 160, it's right above there. So we can estimate it to be about 161 pounds. But graphs are only estimates. Graphs are not perfect unless we graph them on our graphing calculator or Desmos and get the actual value, which is great. But so what we can do is algebraically then confirm what we have by substituting in. So if we wanted to estimate where the height was 71 inches, the height we know is X, so we can substitute that value in for X. And here's the output that it gives us for Y, 160.7. So our estimate of 161, which is very close to that, is a good estimate based off of our table and our graph. We can check it algebraically. So that concludes our notes for lesson 6.1. So here's your assignment on page 78. Just make sure you copy it down correctly. You're doing 1 through 6, all of them, 7 through 29, only the odds, 33 to 36, 61 to 71, only the odds, and then a couple applications, 76 and 80. I also have an answer key posted, so keep in mind I do need to see your work on all of these because you have your answer key, and I want you to use that answer key as a resource to check your answers, and if you have something wrong, figure it out why it is wrong. So let me know if you have any questions on this, please.